DNS-over-HTTPS tech webinar, How to Upgrade Existing DNS Resolver. So my name is Lars Steffen. I'm Director International at ECO, Association of the Industry, and together with Lydia, I'm your second moderator for today's session. And on behalf of ECO, I'd like to welcome you also to this webinar. This session is a collaboration between CENTR, the Council of European National Top-Level Domain Registries, and ECO, Europe's largest association of Internet infrastructure providers. And I'd like to take the opportunity as well to thank everybody involved for making this happen. I'd like to introduce you now to the housekeeping rules of today's webinar. So this webinar is being recorded now. So if you don't want to be part of this recording, you now have the chance to drop out, but I hope that we don't choose this option. The recording will be available for members of both organizations after the webinar. You are muted throughout the webinar. If you would like to ask questions, those will be answered at the end of the webinar, and we have a dedicated slot for this. Questions can be submitted via the chat. Please mark them with questions so that we can identify them and if we have a stream of other comments as well. You can also submit your questions verbally by raising your hand. If you raise your hand, we will unmute you, and if you're unmuted, please state your name and affiliation first before asking the question. You will receive the slides and the workshop material after the webinar via email. On top of that, I will share in the chat 2 links because CENTR already published a discussion paper on DoH in June 2019, and ECO did this in September 2020. So this will give you some more background information on DoH. Today, we would like to focus on the technical aspects of DoH. And with this, I would like to hand over now to Carsten Strothmann. Thank you.
Thank you, Lars. So sharing my screen. Okay, how to upgrade an existing DNS resolver. Before we start, a few sentences about me. I'm a DNS nerd. I'm doing DNS now for some 30 years, I guess. And I'm interested in transport encryption, that is DoT and DoH. And I followed the heated discussions in the last years about that. And today, I can't go deeply into that discussion. So I will talk a little bit what DoH and DoT are and why they are here, but just briefly. So I'm not going into the political bits because the main objective here is to show you the technical part. That is how you can enable DoT and DoH on an existing DNS resolver. So let's jump in. So we start with the issue of DNS privacy and then what is exactly DoH and DoT. I have collected some information about the current status of the protocols and especially on client support. And then we go into the practical part. I've created 120 virtual machines in the internet, and you will be able to log in there and upgrade an existing DNS resolver, which is a Bind 9 system, with DoH and DoT. And you will see it's not rocket science. It's easy to do. So yeah, about me, I'm working for SYS4 in Munich. We're not helping customers installing and maintaining their DNS. I'm also a trainer for DNS and DNSSEC, for DANE, for DHCP, and for IPv6. And occasionally, I find time to go to RIPE and ITF meetings and collaborate there. So what about privacy in DNS? So in the recent years, the ITF had expanded the DNS with new privacy features. And the 2 that we will discover and cover today is DNS-over-TLS, which enables transport encryption between the client and the resolver. And also the bigger brother, DNS-over-HTTPS, which is also transport encryption between the DNS client and the DNS resolver. But there's more like QNAME minimization and EDNS padding, which are not part of this webinar. So why do we need DNS privacy or more DNS privacy? During ITF 105, that was in summer 2019, researchers presented a study where they found out that 8.5% of all networks worldwide intercept DNS queries. So in between, on the way between client and resolver, the packages got intercepted. The number is even higher in China and possibly in other countries as well. So the 8.5% is the average worldwide. What they also find out that today, most of the queries that has been intercepted have been answered unaltered. So someone is just snooping, someone is just listening, reading the data without changing that. But so once the system is in place to intercept DNS queries between client and resolver, it would also be possible to change the data in there for many, many reasons. So because of that, and prevent interception of traffic between the client and resolvers, two new protocols have appeared. And the first one is DoT, DNS-over-TLS, which is RC 7858. And that defines how to send DNS queries over TLS using TCP. So this is basically the plain old good DNS that we know and love, but wrapped into an encrypted TCP channel with TLS. It runs on port 853, and it gives us encryption and authentication. And the authentication can either happen through the Internet PKI, read X509 certificates that we all know from the web, or it can be done via DANE. So you create a self-signed certificate and you create a chain of trust, not through certification authorities, but through DNS and DNSSEC, which I personally, as a DNS person, favor. And then the bigger brother is DoH, DNS-over-HTTPS, which is RC 8484. And that defines how to send DNS queries over HTTP, which is the same protocol that the web browsers talk to the web servers. And because that is standard HTTPS, it runs on the same port as a web server, as an encrypted web server, which is port 443. It is only standardized for HTTP2, which is the newer of the HTTP protocols. So the URL to be used is something like HTTPS://, then the server's domain name /DNS query ? And then the query after that. So it gives us encryption and authentication, which is the same that DoT gives us, but this gives us also some cloaking, meaning that we can hide the DNS traffic inside the web traffic. And from the people who invented DoH, it might, their idea was that it might be harder than to block specifically the DNS traffic when it is hidden in the web traffic. So the differences, DoT runs on a dedicated port, which is 853, which either makes it easy blockable, or even worse, it is mostly blocked in firewalls today because that port hasn't been used in before. And people who want to try and want to use DoT from the client side often find that they can't go through on that port to the internet, because somewhere on the way, some firewall is blocking that port. DoH, on the other side, looks like normal HTTP traffic. So selective blocking of HTTP and DoH is very difficult, or at least is somehow difficult, more difficult than DoT blocking, because just blocking port 443 would mean no web, which for most people means no internet. So also DoH seems to be easier to implement, mostly because of existing HTTPS library function in programming language. So conceptually, DoH is much more complicated than DoT, but because there are a lot of developers out there that know HTTP and HTTPS and know how to use the libraries that exist, it seems to be easier to implement in the application side. And also DoH enables the developers to do name resolution on an application level. For example, they can now look up SRV records and TXT record stuff that was previously not easily possible from a web application running inside a web browser. Some people are happy about that. Other people think that it's a very bad idea to allow application developers to do that. So what is the current status of DoT and DoH? One of the first movers in the space was Firefox and Mozilla. They created the Trusted Recursive or Remote Resolver program, TRR. And to my knowledge, there are currently two or three parties involved there, which is Cloudflare, which offers a DoH server, and Cloudflare is the default in Firefox. And there's NextDNS, and there's Comcast Xfinity coming into the browser as well. And Mozilla started an automatic rollout, at least in the US in February 2020. I'm not sure if they already started a rollout in the rest of the world and in Europe, because there were still open questions about that. And then there's the Chrome and Chromium browsers. So everything that is based on the Google Chrome engine. And DoH is enabled, is implemented there and can be enabled by the user, but it requires an active action by the user. The user must go into some configuration setting and enable it there. But Google is experimenting with DoH auto upgrade for the configured DNS resolver, meaning the resolver that the client has received through DHCP or to a router advertisement. And also the new adaptive DoH resolver discovery that has been implemented already by Apple in their latest operating system is being tested by Google as well. The Safari browsers, which are on the Apple infrastructure, supports both DoH and DoT in iOS 14 and macOS 11, which have been released in September last year. And Apple is also working in the IETF about the adaptive DNS resolver discovery, and they might also support that as well. Android supports DoT since Android 9, so already a few years now, but it's a manual setting. So people need to go into their settings in the Android operating system and select Secure DNS there. And if they do that, it allows auto upgrade from the configured DNS resolver. So again, the DNS resolver that has been received through DHCP or other means will be probed for port 853, the DoT port, and if that is available, the Android operating system will use that. So Apple macOS 11, besides the support in the Safari browser, also supports now DoT and DoH on the operating system level, which means that it's possible for the user to have a global or per application resolver selection. The encrypted DNS configuration is possible to be requested by applications, mostly on the iOS and iPadOS platforms, and users then can choose to allow the application to use that. It's also possible that the OS can learn the per domain settings via the new HTTPS record. So these are all the ways to discover DoT or DoH. And Microsoft with Windows 10 will support DoH in the upcoming February or spring release of Windows 10, spring 2021. It's already in the inside build, the preview builds of Windows 10. And customer can enable that via registry key or via a GUI. And it uses the DNS resolver in the network, so it does an auto update to DoH. And then on Linux, we have DoT support in systemd resolved for some time now, for multiple years, but it's opportunistic mode only, meaning it automatically falls back to classic DNS if DoT is not working for some reason, and it doesn't do any server authentication. So a man-in-the-middle attack is possible here. It allows a global or per interface setting, so you can have different DNS resolver settings on each interface. For example, if you are connected to the internet with one interface and to a company local network with the other interface, you can use DoT on the internet, but classic DNS on the internal side. But it's also not enabled by default. The user must go into some configuration and enable that. And then OpenBSD, one of the BSDs that are that has a focus on security. They have DoT support in a daemon called Unbound. It's also, again, not enabled by default currently, but there are plans to enable it by default in a future version. It does opportunistic auto-update, but it can be also switched into a strict mode where it only does DoT. And if DoT does not work for whatever reason, because maybe port 853 is blocked, it will not do any DNS resolution and will not fall back to classic unsecured DNS. And it does proper server authentication with the TLS certificate, meaning man-in-the-middle attacks are not easily possible. So that was the current state of the affairs around DoH and DoT. We see that there's a lot of movement there. All the big players, all the big operating system vendors and the browser vendors, they jumped on the bandwagon either on DoT or DoH or both. My guess is that at one point of time, users of these operating systems will request these services from their providers and other people who operate the networks. So it might be good to think about providing DoH or DoT in such a network. And this is the idea behind this webinar, to show how to do that. And my part here is how to do that without touching the existing resolver infrastructure. The colleague Thomas from the NOT resolver team and Zizitnik will later talk about how it can be done on a resolver software that has DoH and DoT directly integrated. And there are pros and cons. So here is the deployment with a proxy. And this is the state of affairs before we enable DoH and DoT. So we have a DNS client that today talks over DNS over UDP or TCP port 53. That is classic DNS without transport encryption. The query goes to a DNS resolver, and from there to the internet DNS. And it comes back on the same way. So it's all in the clear and it's not secured. With a DoH and DoT proxy, we have an additional machine, or it could be a process on the same machine, doesn't really matter, that provides DoH and a DoT. And so a client that has DoH and DoT can then request encrypted DNS data from that machine. And the proxy machine will forward the query over classic DNS, that is UDP and TCP port 53, to the existing resolver. The really nice part about that infrastructure is that it scales very well. So you can have multiple of these proxies querying to forwarding to your existing resolver infrastructure, and you don't need to touch the existing infrastructure at all. Of course, the network part between the proxy and the resolver should be a trusted network, so that no attacks happen there, because on that way it's again unencrypted because it's classic DNS. So why would we use a proxy for DoH and DoT? It's easy deployment. The existing resolver infrastructure does not need to be touched, and you can scale that through separate hardware and server instances. And it's also possible to use hardware TLS acceleration, which is part of some commercial offerings. So all the companies, or most of the companies that provide TLS offloading for web services now also provide offloading for DNS in their products. But there's also cons. So why not to use the DoH and DoT proxy? It's additional complexity. So you have another machine that you have to maintain and monitor and update and all that. It is additional latency and less performance because the query goes through an extra machine before hitting the real resolver. If you have everything in one machine and one resolver, that one hop is eliminated and it's a little bit faster. And Thomas will talk more about the pros and cons in the upcoming presentation. So now let's jump into the hands-on part. You find the instructions on this website, which is DoH default routes.de, Echo workshop. I will copy that in the chat in a moment. And every participant gets a virtual machine. And there's a table on the instruction page that lists all the names that have registered for this workshop and a number. And you have to replace every occurrence of XX. Actually, it's now 3 X's because we have a 3-digit number of participants. We hadn't had that so while I was preparing the slides. So you have to replace all the triple X's there with your participant number in the instructions. Use the chat if you have any questions. With that number of participants, I can't answer the questions over the voice, but I will try to answer questions over the chat. Spare your questions about general DoH and DoT and deployment for the later panel. I take questions now directly about the installation process and the practical stuff here. And please raise your hands or yes, thumbs up, something like that in the conferencing tool to indicate when you are finished with the setup. I have to mention that this is not mandatory and you will not be rated. So if you don't like doing the practical stuff, you can just skip that over. We will have 30 minutes for this. So let me see, I open the web page here. And I copy the URL in the chat in a moment. So this is the URL. And you see the detailed instructions in there. And you see here all the names. Look for your name in there. Find the number. And that is your participant number. It's a long list. And then it starts by installing DNS-dist, which is a very nice load balancer from the nice people from PowerDNS. And especially DNS-dist makes it very easy to upgrade an existing resolver with DoH and DoT. And with that, engage.
Carsten, there's a question. What should people who don't have a number do?
Can you repeat, please?
If people don't have a number or can't find their name, what should they do?
Unfortunately, there's nothing I can do now because I can't spin up new virtual machines, not just now. We probably have some no-shows, but it's hard to tell which machines are not in use.
Yep, I can have a look at the no-shows. If you see Lydia Stoddart, you can use that one, and I'll try and see any other names, or I'll put some numbers in the chat that are free.
Yeah, but you need to assign the names to the names that are the no-show names to the names that are here, because everything else, it's not good if 20 people go to Lydia Stoddart's machine. Everyone needs a single machine for that to work. Also, I make the Ansible scripts that I use to set up the virtual machines. I make that available later on. and we send that out by email with the slides. So if you like, you can recreate that environment on any virtual machines out there, and you can, and the instructions will also be online later on, so you can repeat or do again the instructions. So it seems we have a few VMs free now. Very good.
Is there anybody who would like to participate and is still struggling maybe to log in?
Karsten.
Yes, seems to be there's on some machines, the certificates are not correct.
Yeah.
Unfortunately, there's nothing I can do quickly about that. If you know how to create a self-signed certificate, yeah, please go ahead. I think a minute about that, how that is fixable.
Try to get a certificate via certbot, but it appears that Dane.onl has hit rate limits.
Yes, I run in that problem. So I switched for the later machines. I had to switch for self-signed certificates that I created with OpenSSL, and it seems to be that something was wrong in the Ansible script at that point of time.
Yeah.
But the first 50 should be okay.
And it's good I'm not in there because I have installed dnsdist before.
So installing DoH and DoT with DNSdist is easy because the first participants are already ready after 8 minutes. That's impressive.
There are a couple of questions, one from Jaromir from CZ.
It's not a question. There was an instruction at the end to raise the hand.
Sorry, yes, ignore me.
So it seems to be machine 22 is also available. If someone had one machine with the broken certificate, you can jump on 22. So in the chat, Patrick Kötter has posted the command how to create a self-signed certificate that can replace the broken one. So we're slowly coming to the end of the hands-on part of this webinar. Don't worry if you haven't finished yet. The virtual machines will stay online until 8 o'clock CET tonight. So you can continue after the video from Thomas and the panel discussion. The instructions will stay online as long as the server is online there, at least for the next month or so. And with email, you will get the slides of the instructions as PDF, and also a link to a GitHub repository that contains the Ansible scripts that I've used to set up the virtual machines. So if you like, you can recreate the environment that we have today for yourself or your friends. Please, about the questions, please hold the questions now until the panel discussions, and I will be happy to answer your questions there. I hope this was fun. Lydia?
Yep, thank you, Carsten.
Thank you.
I suggest all of you lower your hands now, and I'll share Tomas's video. Bear with me whilst I find it. There we are.
Hello, my name is Tomáš Křížek. I work as a software developer at CZNIC. I'm one of the maintainers of DNS Resolver, and today I'd like to talk about deploying DNS over TLS or DNS over HTTPS on a resolver. First, let's look into the motivation of why would you want to provide a DoT or DoH service to your clients. If you use these protocols, then the data is basically encrypted in transit, so nobody on the network can really snoop into the contents of the DNS queries and replies that are being exchanged. Next, you might want to do this to prevent some of the attacks that would be possible on plain UDP DNS. Although if you really want to assure authenticity of the data, then you should really deploy DNSSEC either on the domain, on the authoritatives, but as a resolver operator, the best you can do is just turn DNSSEC validation on. Finally, the main reason you probably want to provide the DoT and DoH service is because of your clients that wish to use that. Some of the main clients for DoT are actually Android devices because they do opportunistic DNS-over-TLS, and also some forwarding resolvers can be configured to use this protocol. When it comes to DoH, the main clients are really the browsers that support it in their interface. So I'd like to do a brief comparison of these two protocols. What they do have in common is they are built on top of the TCP and TLS layer. The important bit that does the encryption is the TLS layer, and that is present in both. However, where they differ is what happens inside the encryption layer. And for DNS over TLS, there's just a very simple format that has been with us since the inception of DNS, and it contains no extra unnecessary data. It's very minimalistic. With DNS over HTTPS, however, you need to put the entire HTTP protocol inside the encrypted layer. And HTTP protocol isn't actually one thing. There are multiple versions that have almost nothing in common. And I just want to stress that for DNS DNS-over-HTTPS, you certainly want to use HTTP2, since the older protocols have their own issues that also affect like the speed of the resolution. But then even if you use HTTP2, then you get either the GET method or the POST method. It's just really complicated. But once you actually establish that, then you also need to actually exchange the DNS messages somehow. So then you have a new format that is on top of the HTTP protocol itself, and then you finally have DNS-over-HTTPS. So all of this probably seems very complex, and it's because it is. To illustrate that, I have an image that compares what happens inside the encryption layer, and the colored boxes is actually the content, the DNS query and the reply. There are actually two pairs of those. And inside DNS-over-TLS, there is no extra metadata, no anything. It's just the 2-byte length. And inside DNS-over-HTTPS, and let's assume we use HTTP2 with the GET method and not any of the others, there's a lot of extra chatter and complexity that is going on. The problem with this is that it introduces additional attack surface. It has some extra the metadata that can be used for fingerprinting or identifying the clients, such as the headers. But if you want to know more about this, then I go into some more details in my blog post. So let's say you decide to deploy DoT and or DoH. So what are your options? Well, first you can use a proxy such as dnsdist or DNS proxy or some other. I'm sure there are others. Or you can go for a built-in support that comes with the resolver. As of February 2021, both DNS Resolver and Unbound have native support, and as far as I'm aware, the Bind 9 has finished their development of it, and it's probably going to be released soon, but I don't know the details of that. So let's compare these two options. Let's say you want to use a proxy. Well, the good thing is that you can use it with any resolver implementation, older versions that don't necessarily have a built-in support. And you can also offload the overhead of TCP and TLS. And this is really establishing a TCP connection, and the TLS handshake is really where most of the performance overhead comes from. So it can be used for things. On the other hand, using a proxy can be quite complex because it introduces a separate component. That means you have a separate different configuration file, you have another service that you need to care about and monitor, and there's just a lot of things a lot of moving parts that can potentially go wrong if you use multiple components. Another thing that can be an issue is that the resolver loses the information about the IP of the client. This can be a problem if you do some filtering based on the source IP address. And finally, I think the performance probably isn't as good as the built-in support. Specifically, I've benchmarked dnsdist against Unbound and DNS Resolver, and the performance is just nowhere near as good. But it depends on the implementation, and this might not apply universally. So always make sure to benchmark and test whatever it is that you choose to deploy. So the other option is to use a resolver that has a built-in support of DoT or DoH. The good thing about it is that the configuration is typically really simple. It's just 2 lines in a configuration file. As I've talked about before, this seems to be able to achieve a much greater performance, but also it seems to be more reliable and stable than some of the other solutions. The downside is that it requires a support in Resolver, and these have been fairly recent additions. So for not Resolver, you need to have a version 5.2 or newer, and the recently released Unbound also had this support. So once you deploy the service, what are the utilities and tools that you can use to do some checks, benchmark testing? One of these is KDIG. It is very similar to the DIG tool. It comes with not DNS, and it can be very useful for some basic sanity checks. You can just do a single query over the selected protocol, whether it's DoT or DoH for both post and get method. You fire off a single query, and you basically see the results. This can be very useful for some basic sanity checks. Another utility that can be used for more functional and performance testing is Flamethrower. I haven't used it much, but it looks very promising. It has an interface that is similar to DNSPerf. And the great thing about it is it can generate the query traffic and then basically send it to your resolvers over the connections that you configure there. This is somewhere in between a full realistic benchmark with your own data and a simple check. It's like it's a good performance testing tool, but it does not necessarily represent the clients realistically. If you want to do really realistic benchmark for DoT or DoH, I would recommend DNS Shotgun. It's a tool that we've written specifically for this purpose. What you can do is it can simulate hundreds of thousands of clients. The drawbacks of some of the other tools are that they establish a certain number of connections and then send the queries over them, which isn't really how your real clients are going to behave. Because first of all, your real clients will have a lot of connections. Each one of them will have at least one. And they will, open the connections, close them, etc. So the number of connections are also going to evolve over time. And a lot of the overhead when it comes to these services comes from handling these connections. So being able to simulate them realistically is quite important to have a realistic benchmark. So what this tool can do is that basically you capture your traffic, or the traffic of your clients, and then you can replay that, but over different protocols. So you can choose to replay it over DoH or DoT, and you can even choose to replay it over multiple protocols at the same time and get the result separately. So you can, for example, say, what would happen if 10% of my clients started using DoT, 10% started using DoH, and the 80% would keep using UDP. And you can actually replay this scenario and then see what would happen, how would the latency for the clients look like, what would be the load on your servers, etc. DNS Shotgun also comes with a very comprehensive benchmark documentation, so it has a lot of information, and I recommend you check it out. So based on our experience with these benchmarks, what is it that we can recommend? I definitely recommend using ECC or elliptic curve based certificates. Because if you are going to use the RSA cryptography, you can expect a much larger overhead, and I just wouldn't recommend that. It's very important that you benchmark with your own traffic, with your own clients, to get an idea if your service can actually handle the load and if you're actually able to provide a reliable and stable service. When it comes to overhead of DNS over TLS and DNS over HTTPS, what we found out is I initially expected that the DNS over HTTPS will have a larger overhead, and it does, but it is not significant. The significant overhead really comes from establishing TCP connections and adding TLS encryption. So both of these protocols have comparable performance. When you compare this, however, to UDP, plain DNS, then you can expect about 3 times the performance overhead. And a former colleague of mine goes into the details of some of our results from benchmarks in his DNS org talk. So if you're interested in that, I definitely recommend that you watch this talk. Finally, if you want to provide a really resilient service, you probably want to use multiple different implementations of the resolver. Because let's say there's a 0-day exploit or some vulnerability that hasn't been patched yet, and if you rely on a single implementation, that's a real challenge for your infrastructure. If you use multiple implementations, for example using Anycast, then you have, if you diversify your infrastructure in such a way, it's just going to be more resilient. So to sum it up, if you're going to deploy DoT or DoH, decide which one, and you're probably going to deploy both, since the clients, there are different kind of population of clients, right? The mobile devices, they want to use DoT, the browsers, they want to use DoH. So there's really no reason, if you're going to deploy DNS over HTTPS, you probably have no reason not to deploy also DNS over TLS. Then you also have to decide, do you want built-in support in the resolver, or are you going to use a proxy as a separate component? My personal recommendation, based on the benchmarks that I've done, would be to go for the built-in support if your infrastructure allows it, if you are able to use a sufficiently new version of the resolver. And finally, the most important recommendation is to really test and benchmark your own setups. A year or two ago, the tools just weren't there, but the situation nowadays is different. These tools are available, and you should really take advantage of that, because you can discover some issues before you put your service to production, and you can also use the tools to plan your infrastructure properly. So if you're interested more in DNS Resolver, you can check out our website. We also offer both free and paid support. If you're interested in DNS Shotgun or have any comments or questions, you can use the issue tracker or reach out to me directly. That is all. Thank you for your attention.
All right, thank you, Lydia, for sharing the video. So Tomasz wasn't able to be with us right now, so he pre-recorded his presentation for us. But with us is also now Erwin Lensing. He is co-chair of the Research and Development Working Group at CENTR. And together with Carsten, he will be happy now to take your questions. You can use the chat, and of course you can raise your hand.
Don't be shy. Maybe we have already answered all questions. I don't think so.
Yes, we have the first hand from Peter Koch.
Yeah, thanks, Lars. I get paid for that question, of course. Peter Koch from DNIC. I remember that there were lots of promises coming together with the introduction of DoH and DoT, and one was that it would actually be a performance boost, as in lower latency for the end user, as a reason to integrate the DNS resolution over HTTP into web browsers. Is anyone aware of more recent research that could either confirm or deny that claim, or find out what the peculiarities of that performance boost are? Thank you.
So I only know about the studies done by Mozilla, which state that in lossy networks, so where occasionally a packet will disappear on the way, that a TCP connection, either DoT or DoH, is actually faster to recover than UDP, which will wait for a timeout. But I don't know about any recent studies. Anyone better information there?
Yes, I just wanted to ask Evin, maybe you would like to chime in. Or not? Oh, we proceed to the next question. So the next hand raised is from Andreas Schulze. So Andreas, please unmute and.
Yeah, hello, Andreas Schulze, out of Germany. Question about production use. Are there other infrastructures known beside the large ones, Cloudflare and Google, which really use DOT or DoH on production level? And are there any experiences known? Or does anybody of the attendees have experience? That would be interesting.
I only know about some testing installations, and yeah, I can't really give much input on that.
There are a few smaller installations, and there might also be local ISPs doing it for their own customers, but I'm not aware of anyone doing it for as an open resolver for everybody.
Okay, thank you. So the next hand that we have on the list is from Peter van Dijk. Peter, the floor is yours.
Hi, I can respond to both of those questions. As
That's
I have
good.
interpreted the Mozilla reports they did, their first report was DoH is way faster, more reliable, etc., etc. Then there was a second report about lossy connections, which my recollection is different than Carsten's, that in lossy situations, actually the TCP stuff breaks down a lot. And from those things, I gather that their first report about DoH being better is more due to their re-engineering of the stack than an actual protocol difference. But it all does depend on network conditions. As for Andreas' question about big deployments, I know Quad 9 serves billions of questions a day, a big chunk of which is being served over DoH and DoT by DNSdist. That's all I have.
That's great. Thank you, Peter.
I think from what I heard when this was just coming out, especially about DoH, was the big performance was doing what I would call pipelining, where you can actually do the connections simultaneously or ahead of time rather than waiting for getting the HTML or rather embedding it into the first response from the web server, where it already includes some of the DNS answers on the servers that it will need next for like included JavaScript, etc., which in the usual case you have to do afterwards. I think there's a real chance for a big performance increase, but I'm not aware of any of the browsers actually have implemented that yet.
I'm not aware of DNS push happening from websites, although there's been a lot of talk about it. But the pipeline again comes down to something that they did not do for UDP and are doing now. Not a protocol difference, but an implementation improvement that happens while they were doing everything.
Thank you, Peter. Do you have an additional question, or is this an old hand on the list? Okay, thank you. Do we have more questions from the floor? That's obviously not the case. Carsten, Erwin, any final remarks from your end?
Yeah, my remark would be that my gut feeling is that DoH and DoT will not go away. They will stay. And currently the load is still quite manageable, even if the installation and implementation is not fully tuned. So I think it's still a good time to start getting experience with DoH and DoT before it grows.
I can only agree on that. It will not go away. I think some of the discussions have been more on the political side rather than the technical side as to who do you trust with your DNS, well, your DNS queries and the traffic you're going to, which of course is very different in like the US than it is in Europe, but it has nothing to do with the technical stuff. I hope we're going to see more ISPs adding DoH or DoT besides their normal resolver offerings. But yeah, the technique is not going away. I completely agree on that.
Okay, thank you, Erwin. So this is the final chance now to.
There's a question in the chat.
Yes, there's a question in the chat.
What is about DOQ, which is DNS over QUIC? And QUIC is a new protocol that was originally designed by Google and is now being standardized in the IETF. And it is something that could replace TCP in the long run. It's based on UDP, but it has the features of TCP. So once DOQ, DNS over QUIC, or in general, once QUIC was appearing at the IETF, there were a lot of some protocol over QUIC working groups being forming, and a lot of discussion about that. And one of them is DNS over QUIC. I guess it will at some point be some kind of an RFC from the IETF. Whether it will see widespread adoption, that really depends on whether QUIC will see widespread adoption.
And we have a follow-up question in the chat on this.
Yeah, the question from Patrick is, wasn't QUIC encrypted by default? Yes, it is. Basically, it implements TLS 1.3 and possibly newer versions directly in the protocol. So at least from the planning from the IETF and from Google, there wouldn't be a QUIC version that doesn't include TLS encryption. And because it's directly embedded in the protocol, it is possibly a little bit faster than what we have now.
And we also have links to additional information on that. That's very useful. Thank you very much for posting them.
Yeah, Andreas is asking if I could say some words about auto update, which I understand is the feature that some of the DoH clients and DoT clients have. Basically, the challenge for clients today is to find out whether there is a DoH and DoT service in the network. So what some of the clients are doing is they read the DNS Resolver information from the operating system, which have either been learned by DHCP or by IPv6 route advertisements, or have been manually configured, or have been configured by something like DOCSIS or something like that. These clients then will use that IP addresses, but not send classic DNS over port 53, UDP and TCP, but instead they will probe port 853 for DOT and maybe port 443 on these machines. And if they are available there, then they will use these encrypted protocol instead of the classic DNS protocol. I hope that answers the question.
Thank you very much, Carsten. Yes, that's obviously the case. Thank you. So we reached the end of our 90-minute slot. So I would like to take the opportunity to close the row for questions. I would like to thank our speakers and to thank all participants for joining this webinar. And we hope that the last 90 minutes have been interesting for you and provided useful information. As we already said, the slides of this webinar will be shared after the meeting. And of course, we would be very pleased to welcome you again at the next joint webinar of CENTR and ECHO in the future. And from my end, I would like to say thank you very much and have a nice rest of the day. Take care and goodbye. Lydia, I hand over to you.
Yes, I can't add anything to that. So thank you all of you for joining us and hopefully see you online soon. Have a good evening.
Thank you all. Bye-bye for now.
Thanks.
Bye.